So we got a few people successfully passing the test. So if you want to check out the reference implementation, what you can do is first save your current work, commit it, and then do git checkout solutions. And this will put you in a branch where everything is completely implemented for you, so you can reference what it is doing. So yeah, this is actually pretty straightforward. So we first use object.keys to get a list of the current existing properties, and then we iterate through that keys array. And for each key, we get a closure here, right? So that gives us some opportunity to just store this, to store this variable here inside this closure. This is the internal value. And remember to assign it to the initial value of that original property. Otherwise, you'll get undefined on the first access. And then we use define property to override it. So I'm omitting all the extra enumerable stuff here. But remember to think about them for your use cases in real applications. And then inside the getter, we simply log the internal value via the get access and return the internal value. This will retain the original access behavior. And inside the set, we'll just set the internal value into the new value and log the set operation. So any questions? All right, good. So let's move on. So switch back to the master branch so that you don't see the solutions for the next exercise. And then open 1.2.md. So now we're getting into something called dependency tracking. Okay, so dependencies. So how do we abstract the concept of a dependency? Let's just create a class. Okay, let's create a class called dep, and this class will have two methods: depend and notify. Depend means the current code that's executing depends on this dependency, right? And notify means this dependency has changed. So any previous expressions, computations, functions that have previously depended on this dep should be re-executed. They should be notified. What this means is we need to find a way to associate a piece, a function, or a piece of expression, or a computation, I would call it, associate a computation to a dependency. And this computation should probably be considered something like a subscriber of the dependency, right? So that's how the dependency class works. And then we will have another function called autorun. And what this autorun function facilitates is that it'll take an update function or a updater function or a computation, as I would call it. So this update function, when you enter this updater function, everything becomes special. We're in the reactive zone. So when you're inside this reactive zone, you're able to register dependencies. So let's take a look at how that would actually work. So the expect usage looks like this. All right. So we'll have the dep class. We'll create an instance of the dep class called dep. So this represents a dependency. And then we'll auto-run a computation. And all it does is the side effect we're producing is just a console log. Okay? But the important thing here is inside this computation, we're calling dep.depend, which associates this function, this computation, to this specific dependency. So we are essentially adding this function into the subscriber list of this dep. Okay? And later on, when you call dep.notify anywhere else, it doesn't need to be inside an autorun or anything. When you call dep.notify, this function will be called again. Does that make sense? So the API is actually pretty simple. Like all you need to do is create the dep class and the autorun function that makes this code possible. So similarly, you can run the test with this. And if you look at the file, the boilerplate is pretty simple. We just ask you to implement this. So it takes a little bit of a trick. So let's start working on this for 10 minutes, I think. I'll try to see how everyone's doing and provide some hints as we go half through the time. Okay? So I'll switch back to this. This is the expected usage. Okay.
10 minutes.
Yes.